Hi, everyone. Hello. Welcome to the very first seminar of the Health Terminology and Interoperability Standards Seminar Series. My name's Linda Bird. I'm an adjunct assistant professor here at the University of Victoria and also the instructor of HIMP 597, which is the field project in health informatics. And we're hosting this seminar series. Before we get started, let's begin with our territory acknowledgement. We would like to acknowledge and respect the Lekwungen peoples on whose traditional territory the university stands, and the Songhees, Esquimalt and Wasanich peoples whose historical relationships with the land continue to this day. So, as I said, today is the first seminar in the HTIS seminar series, and we are very lucky to have Derek Ritz with us today to talk about standards-based digital health architectures. But before we get to that, let's take a look at the next few weeks. Next week, we have Alejandro Lopez Osornio from SNOMED International coming to talk to us about SNOMED CT trends and latest developments. On June the 24th, we have Dr. David Hay, who will present on HL7 structured data capture. And the fourth seminar, because of Canada Day on Tuesday, July the 1st, we're shifting week 4 to Thursday, July the 3rd. And for that seminar, Lynn Nagel and Peggy White will come and talk about nursing data standards in Canada. And then finally, on July the 8th, Debbie Pinter, Debbie Onus, and Laurelie Lawson will be presenting on building a better health record at Alberta Health Services. So there's a lot to look forward to over the coming month. And these sessions will be recorded and shared on the school's website. Now, if this seminar series interests you, then you may be interested in turning your interest into a qualification by enrolling in the Certificate in Health Terminology and Interoperability Standards. This is a one-year part-time program with 4 graduate level courses, including this one, which are done through weekly online evening classes plus a virtual workshop. This is the only terminology standards program in Canada that's accredited with CHIMA, the Canadian College of Health Information Management, to become a certified terminology standards specialist. So if you'd like to join our September 2025 intake, the deadline for applications has been extended to July the 1st. So please either scan the QR code or go to uvic.ca/HIMF and then click on certificates. So today I'm delighted to introduce a friend of mine, Derek Ritz, who I used to run into in the most interesting countries. Derek and I have got quite a few travel adventures to tell, which Derek is the principal consultant at EC Group Incorporated, which is a Canadian professional services firm that provides expert advisory services to domestic and international public and private sector clients regarding digital health strategy, architecture, standards, implementation, and adoption. He has been an advisor to national scale and international scale digital health infrastructure projects in Canada and the EU. He was a member of WHO's core COVID certificate team during the pandemic and has worked in over a dozen countries in Africa, the Middle East, and Asia. Derek is active in IHE International. He's a delegate of Canada's ISO TC215, which is the Health Informatics Technical Committee, and is an HL75 Foundation founder. He was a launch partner and active contributor to the donor-funded initiative Open HIE, whose mission is to improve the health of the underserved through the open collaborative development and support of country-driven large-scale health information sharing architectures. And so Derek is going to present to us today on standards-based digital health architecture. Thank you so much for joining us, Derek. Over to you now.
Thank you, Linda, for inviting me. And I'm going to start sharing my screen. And can I just get a confirmation that everybody is seeing in display mode my
Yes,
deck?
perfect.
All
Thanks, Derek.
right, wonderful. Okay, this in fact is not the title screen for what we're going to see, but it is the title screen of the deck that I developed for the World Bank. There's a link, and I'll be happy to share this deck with everybody, but there's a link to a World Bank website. I worked with them over a 2-year period to develop a buildable digital health blueprint toolkit that could be leveraged. The target for the people that would use this is the 150 countries that aren't in the OECD, and they would leverage this in a workshop facilitated process with a technical working group that the ministry would strike, and to develop as their work product a buildable blueprint and an investment case that showed what would be the benefits of building that out and implementing it in the country, sort of a 10-year investment case. This is what the workshop plan was, and the four that are listed here. The fifth is the investment case, and some countries would choose to do that just within the ministry, and others would do it with the whole technical working group. But this deck that I'm going to use is typically the second of the workshops. The first one is focused on use cases and care pathways. The second is the infrastructure that would be put in place. The third is looking what we call it the Lego blocks one to see what digital health solutions are already in place. And then the fourth one was focused on implementation science. This is workshop two, digital health specifications. And this is the agenda for when I'm doing this in country. And I've done this in about 6 or 7 countries, I guess. Yeah, 7 countries. And this is typically what the agenda would be. And we're not going to do the recap and review because we didn't do a session one. I'm going to do just a super brief bio to do a further disclosure of biases in addition to what it is that Linda used to describe me. And then we're going to talk about the metaphor for a health information exchange. We're going to talk about OpenHIE, the one that Linda mentioned, as an architected approach for data sharing and the transactional model and the data model and so on. And then I'm going to look at an infrastructure for leveraging this OpenHIE architecture using the FHIR standard. Then there's going to be a brief introduction to computable care guidelines. They are very much a part of this overall infrastructure. And I'll say what they are and what kind of value they can bring. And then we'll have Q&A. So, mandatory Canadian apologies. The first of them is that I'm going to have to interrupt us a little bit because I'm going to flip over and try to show a video. Let's all hope that that goes well. Also, for people that may or may not have seen me present on this topic before, I'm sorry, but the material's pretty much the same. The jokes are probably the same. It is what it is. And then the last of the Canadian apologies, just because we have to make them, is that I apologize that I'll be apologizing so much. You know, you're fellow Canadians. It's like a verbal tick that we have as a country. So this is the bit of extra introduction. And as a disclosure of biases, I'm a recovering engineer. I've been in a 12-step program and coming along very well, I'm happy to say. I do have a geeky side, and Linda talked about that. I mean, I've been a delegate of Canada to ISO since 2007. Very involved, including as a technical committee chair in the IHE organization. I've been involved domestically here in Canada on a number of our provincial implementations and an advisor to Infoway. I live half and half in Toronto and in Paris, and have been working on a number of the EU projects, especially ones related to the European Health Data Space, the EHDS, which is a really big deal right now. And having said all of that, over the course of the last 15 years, the the travel log that Linda was referring to, I've been involved in an advisor capacity to these countries. It's not a test to figure out what they all are, but at the top of the screen, you see who it was that I was working on behalf of. So on behalf of the World Bank or the World Health Organization or UNICEF or uh, the US government's PEPFAR program, Asian Development Bank, and others. Okay, this is where I'm going to pause for a second and try to do something that we tested it and it seemed to work. I'm going to actually go to that link and try to show that video. And my little joke there that it's bearable if you do it at double speed, it is unbearable if you do it at normal speed. I'll say it that way because I had recorded it for non-native English speakers. And when I was recording it, I spoke very slowly. Uh, so I'm going to share this screen and play this at chipmunk speed. And let's see how that goes. Is everybody seeing? You see it okay?
This is a Mars story. It provides a person-centric example of how investments in health data sharing infrastructure can improve care workflows and health outcomes. So what could care look like once we have a National Health Information Exchange, or HIE? To explore this question, we're going to follow a health story. Our story has characters. There's a patient. His name is Amar. There are multiple care providers, Amar's family doctor, a private sector pharmacist, and a lab technician. Different point-of-service digital health solutions also play roles in this story: an electronic medical records, or EMR solution, a pharmacy system, and a diagnostic imaging system. Lastly, there is a National Health Information Exchange and a Personal Health Record, or PHR portal, both operated by the Ministry of Health. Let's begin our story. This is Amar. Amar is 36 years old. He lives with his wife and 2 small children in an apartment in the capital city. Amar is a heavy smoker and has been since he was a teenager. He's being treated for chronic pulmonary disease. Last month, Amar purchased his first smartphone. Amar attends his regular checkup with his family doctor. He presents his health ID card. Amar's doctor uses her cloud-hosted EMR to retrieve Amar's demographic record from the national HIE. She updates the record with Amar's new phone number. She retrieves Amar's health summary record from the HIE. Based on the care guidelines for Amar's chronic pulmonary disease, the doctor records Amar's vital signs. His lung capacity reading is concerning to her. Following the guidelines, Amar's doctor changes the prescription for his inhaler. She also orders a lung cancer screening test for Amar. As has been the case in the past, Amar does not agree to try to stop smoking. Amar's health summary is updated with the observations, his e-prescription, and his diagnostic test order. The updated summary is saved to the HIE. Amar accesses the ministry's PHR using his new phone. In his health summary, he sees his e-prescription and his diagnostic test order. Amar goes to the private sector pharmacy near his apartment and presents his health ID card. The pharmacist enters Amar's ID into his commercial software solution. From the HIE, the pharmacist retrieves Amar's demographic record and the health summary record, including Amar's e-prescription for a new inhaler. The pharmacist scans the product barcode, the Global Trade ID number, or GTIN, and dispenses the replacement inhaler. Based on the GTIN, the pharmacist prints the inhaler's product information sheet and reviews it with Amar. Amar's health summary is updated with the dispensation information. The summary is posted to the HIE. On his PHR summary, Amar sees the details of his new inhaler, including the product name, manufacturer, lot number, and expiry date. Amar attends his appointment for the lung cancer screening test and presents his health ID card. The lab technician uses her diagnostic imaging software solution to retrieve Amar's demographic record from the HIE, as well as his health summary, including the order for a lung cancer screening test. The lab technician conducts a low-dose CT scan on Amar. She updates Amar's health summary to note the test results are in progress. The summary is posted to the HIE. She tells Amar he will be notified when the test results are complete. Since the test, Amar has started to make changes in his eating, exercise, and smoking habits. He started tracking his weight on the PHR portal. Amar's scans have been interpreted and his test results have been saved to the HIE. On his PHR account, Amar receives a notice that his test results are ready to be reviewed with his family doctor. Amar attends an appointment with his family doctor to review the test results. He presents his health ID card. Using her cloud-hosted EMR, Amar's family doctor retrieves his demographic record from the HIE, as well as his health summary, which includes details of his dispensed inhaler and of his low-dose CT scan. Following the guidelines, the doctor records Amar's vital signs and congratulates him on the improvements in the readings. She reviews the test results with Amar. Based on his LungRads score, he's scheduled for a 6-month follow-up. This is a wake-up call for Amar. Thinking of his family and his future, Amar finally agrees to try to quit smoking. His doctor encourages him and enrolls him in a stop-smoking program run by the community clinic near his home. Amar's health summary is updated with the observations and the 2 new orders. The summary is posted to the HIE. On Amar's phone, he sees the lung cancer screening results, the follow-up appointment, and his enrollment in the stop smoking program. For the sake of his family, he is committed to making the changes he needs to make. What can we note from this story? Care providers across both the public and private sectors use a wide range of disparate point-of-service digital health solutions. Some solutions are cloud-hosted, others are locally installed. To support care continuity for Amar, all points-of-service solutions leverage the Health Information Exchange to keep Amar's shared health data current and correct. Using the MOH's PHR portal, Amar can access his health summary record. He can also enter personal information that helps him better manage his health journey. The HIE is game-changing infrastructure. It connects the points of care together so they can operate as a system that supports the arc of Amar's health story, now and into the future. But that's not the only win. The ministry can leverage these system-wide data to drive analytics that will inform better decision-making for the benefit of Amar and everyone. Thank you for watching this video.
Okay, that seemed to work all right. I'm going to start sharing the other screen again. And I just am going to do it again because I'm not sure if optimizing for video sharing is something that I need to do every time. So now I'm sharing this one. And okay, well, let's step through the slides that I didn't have to show you because we showed the video and I just wasn't sure it was going to work. So I have all of these in here. And while I'm doing that, I just want everybody to know I'm not precious about being interrupted. Please, if there's something that you're thinking of, all right, we typically would do a question and answer, but I thought, no, we're not going to do a question and answer unless you've got burning questions, in which case I'm happy to do a question and answer. Does anybody have anything about that short video? It honestly is just intended to be answer the question, why would we do this? Why would we go through the process of spending all this money and going through all of this implementation headache? And it is supposed to show what care could look like if we did do that and why it could be beneficial. So if there aren't questions, I'll keep going, but if there are, happy to answer them. Going once, going twice. All
I
right.
don't see any. Um, I think we're right.
Okay. So moving right along, let's talk about OpenHIE. And OpenHIE is a donor-funded initiative. It's been going for 12 years now, I think, something like that. And it's Open Health Information Exchange. The premise here is that OpenHIE is related to enterprise architecture. And there's an absolutely lovely analogy to explain enterprise architecture and how it's different, for example, from solution architecture. Enterprise architecture is like urban planning. And so if you want a city to work, when you build a house, you're going to connect to the sewage system and to the water system and to the electrical grid. And there are standards-based connectors that you leverage so that you can do that, because that gives us a way to leverage shared services, and that lets us go to scale. If you couldn't do that, you had to drill your own water well, and you'd have to dig your own sump, your own septic, and everything else. So this is a way that we can go to scale. And to be honest, all of this governed infrastructure is how we can build big cities and how we can leverage the economies of scale to be able to afford that. And the whole idea maps very well to what health enterprise architecture is for. And some of these patterns map over very well in addition to that. So notionally, there would be an interoperability layer, and point of service solutions shown at the bottom of this diagram would leverage those shared services to access, or leverage that interoperability layer to access the shared services. Now, I'm not going to go into very much more depth than that. The high level takeaway is that this approach, which to be honest was pioneered by Canada Health Infoway, the 2006 version 2 of the Infoway blueprint won a global award in 2007 for its excellence in health enterprise architecture. Over 60 low and middle income countries, that's what LMIC stands for, have adopted this open HIE health enterprise architecture as their national, as the basis of their national health enterprise architecture. It defines the infrastructure and the service specifications that can establish a data sharing network. And for the purposes of the blueprint, the buildable blueprint specification I developed for World Bank, we actually leverage this architecture, or the health parts of it at least, not the financial or supply chain pieces, but we leverage the health delivery parts as the elements of this blueprint. The OpenHIE community has leveraged a portfolio of standards that map to the blueprint elements. And this alphabet soup, these are all different specifications published by IHE. And they're part of the mobile health data sharing portfolio. And each of these, CT is consistent time, ATNA is audit trail and node authentication, PEMR is the patient management, MCSD is care services discovery, and so on. Notionally, all of these specifications describe the ways that you would leverage these shared services using the FHIR standard. Now, that's the transactional side of things. You have now patterns and conformance testable specifications that let you convey stuff. There is now a companion specification for what is the stuff. And the OpenHIE specification has embraced the International Patient Summary, or the IPS, as the person-centric health data content model. So the OpenHIE community has embraced that. So has the Global Digital Health Partnership. So has AHIN. Canada is a member of GDHP, by the way. AHIN is an acronym for the Asia eHealth Information Network. The African HELENA, and I don't remember what HELENA stands for, but it's the African equivalent of AHIN. They have also embraced this. And so everybody knows, Canada's patient summary specification is a Canadianization of IPS. And we made only a very few changes, mostly to the code systems, to be honest. Things like the drug codes and so on are our Canadian domestic drug codes. So there's the transaction processing model, and there's the content model, and there's a core transaction set. So think of this as sort of the Letterman top 10 list. It starts to look geeky with the stuff in the red brackets. ITI is the IT Infrastructure Technical Committee's transaction number 93. ITI 78, and these are just the numbered transactions that are leveraged. So you'd use ITI 93 to add or update a patient demographic record. ITI 78 is the conformist testable specification for querying for a patient demographic record that's already there. ITI 65 is how you would get a patient summary, and the PCC is the Patient Care Coordination Committee's IPS specification. You can query for person-centric health data. You can query for registry content. The registries would be the health worker registry, the facility registry, the health worker facility. Maybe that's it. I think I'm forgetting one. I'm sorry, but it's not going to come to me. You can refresh those registries because there could be a federation of directories underneath. Think of the health worker registry as being a federation of the information you would get from the College of Physicians, from the College of Nurses, from the College of Pharmacists, and you would bring all of that into a health worker registry, an interlinked health worker registry. You can submit aggregate data reports. If you're supposed to be submitting on a monthly basis how many pregnant women you saw, or how many live babies were delivered, or how many instances of a particular disease that came through, or how many vaccinations you did, you'd use transaction 7 to be doing that, submitting aggregate data reports. There's a family of transactions that you would do for number 8. It's to look up and validate and translate between codes. That's a very important one. And that's the interlinked registry and the terminology services. And then number 9, to retrieve and apply computable care guidelines. Again, there's a family of specifications for that. And then the common functions that you would have to do in any secure network, any regulated environment. So security, privacy, auditing, all of those. So there's sort of a top 10 list of FHIR-based transactions that your infrastructure has to do. And I really want you to think for a moment how astounding it is that there's basically 10 things that you have to do. I don't know how many might remember this, maybe none of you, but in the early days of the Pan-Canadian work around our health enterprise architecture, we had something north of 150 profiles, 150 specifications. And what we've found in the fullness of time is that there's about a dozen of them that everybody used, and about 120 of them that nobody used. We had significantly over-engineered this. And in fact, one of the takeaways from our own domestic experience is that there's a relatively small list of things that once you can do them, you can do a health information exchange. You can start to do data sharing infrastructure that you can leverage to better serve your patient population. All right, what are the key takeaway points here? Health enterprise architectures like urban planning. We want to leverage shared infrastructure because this shared infrastructure and these shared services deliver shared benefits, and it is how we go to scale. Open HIE, if the only thing that you remember from it is that it is a widely adopted HEA in over 60 low and middle income countries, it just operationalizes HL FHIR standards-based transactions that together create that health enterprise architecture and operationalize this. And the idea of data sharing infrastructure that's based on this specification is that we have these small Lego blocks that we can assemble into a conformance testable infrastructure. When I was a kid, I don't know if this is still the case, but there were commercials that would play on Saturday morning during the cartoons about Lego and that it's a new toy every day. And they had a little song, it's a new toy every day. And the idea here is that these Lego blocks are completely reusable. But I can tell you for sure, we assemble those Lego blocks differently to make our infrastructure in Canada than how we were assembling those Lego blocks in Tanzania when I was there, helping implement solutions in that context. So they are completely reusable Lego blocks, but you click them together into a different shape depending on the context in which you're going to use them. Okay, I mean it this time. I really will pause for questions. Are there any? I'm going along at best pace. I appreciate that if you're drinking from a fire hose, you might not be able to get your breath long enough for a question. I will be pausing along the way. So if anything comes to you, either wait for the next pause point or, again, I'm not precious about being interrupted at all. If there's something that is an idea and it really speaks to the slide I have on the screen right now, by all means interrupt me. But here I go. Oh, by the way, in the World Bank workshops, we would stop and do these interactions, these interactive web forms, and we would get and show the graphs in real time of how people are answering these questions. But we're not going to do that. And we're also not going to take the coffee break now, which is what we would do if you were all members of a Ministry of Health. Okay, how should we deploy a national infrastructure based on Open HIE on Fire? So firstly, there's some underlying principles here. And to be blunt, at this stage of my career, and I'm just this close to retirement, I actually don't as much as I used to sort of say, oh, well, you can do it this way or you can do it another way. I guess because I've got enough experience to know that some ways don't work and some ways do, and I always go straight to the ones that work. So in terms of design principles, hosted deployment model is recommended. This is not something where you're going to have everybody with a computer under their desk that has to have a, 99.999% uptime. The hosted models are the ones to favor. An online transaction processing server is what we would expect to leverage in this hosted environment, and it will be optimized for performance. And to defend the performance of something that's an OLTP focused server, anything that's related to batch maintenance or analytics where you have to have the computer think about things for a while, that will be separate. You will defend the performance of the OLTP server by having a separate one that does those long running batch maintenance or heavy data analytic processes. So that is, as a design principle, you'll separate the concerns. There is a role for the enterprise service bus. That was that thing in the middle, if you remember the OpenHIE diagram, and it will orchestrate transactions. So if there's a case where 2, 3, or 4 things have to happen, it will orchestrate that they all do in the order in which they should happen. It will centralize security, privacy, and auditing. And it is a very, very useful design pattern to embrace. And again, that's one of the underlying principles that is part of this approach. POS stands for point of service solutions that have to operate in an occasionally offline mode. Keep in mind, I've got a lot of dirty boots experience in places where maybe the electricity infrastructure isn't terrific, or maybe the internet infrastructure isn't everywhere, and you do have to provide services at a clinic that's on the other side of the mountain and doesn't, it's not in the line of sight of the tower. So if there are point of service solutions that have to operate in an occasionally offline mode, they do local caching and they synchronize once they're connected. And I call that out because that's a design pattern. That means that's taken care of on the client side, and the role of the infrastructure is to be optimized for its, fast response time and high availability, and so on. Okay, looking at our core transaction set, this is where you would find them in an architecture diagram for this infrastructure. Now, I'm just going to go through this. At the bottom, we have our point of service solution with a computable care guidelines engine, something that does the processing to say, all right, what things should you do now? It's for clinical decision support. That's what the CCG engine does. CR is the client registry point of service solution, and it might be separate or it might be built into the point of service solution. There are a lot of reasons why you might want it to be separate. For example, it could be issuing cards. So that could be something that's generating a laminated card or a little cardboard card that you put into a plastic sleeve. I mean, something like that is astoundingly inexpensive, and it works remarkably well. These point of service solutions access the hosted solutions, typically through the interoperability layer. It's a design principle that the HIE, the elements that are above the interoperability layer, never talk to strangers. And so this idea of being able to leverage a shared service that does the authentication, that does the authorization, it's a very smart way to do the design. Up in the cloud, you will have the elements of the HIE. And you know what? I'm going to be going through these in more detail, but just kind of left to right in the middle there. There's the terminology service, and the asterisk is because that's the library one. That's the one that you would use in Canada. I think every quarter, we broadcast out the updated code lists. And there's an expectation that they're going to be downloaded by hospital systems, by EMRs at doctors' offices. So that's the library function at the far left there. And you see it's connected to the ILRTS, which is the Interlinked Registry Terminology Services. And that's the one that is optimized for quick response. That's the OLTP version. And so it's basically going to be a set of fire resources that can respond, wicked fast in a few hundred milliseconds. Same with the client registry. You see the one that's got an asterisk beside it? That will be if you have to onboard or change the address for a subject of care. You would do that in the slow running one, the one with the asterisk, and then the data would be updated into the fast running one. Everything inside that orange oval or orange rectangle is optimized for speed. And so content would make its way into the FHIR server as a patient resource. So ILRTS, that's the terminology services. ILR Health Worker Registry. Again, ILR is Interlinked Registry, Health Worker Registry, the Interlinked Facility Registry, the Interlinked Organizational Registry. That's the one I couldn't remember before. And then the Shared Health Record. And then off to the far right-hand side, the cube, the data cube, that's the Health Management Information System. Remember I said that any analytics would be done by a separate system, so it would never slow down that orange rectangle. And then up above, we see health worker directories. So that's the data feeds from the College of Nurses, the College of Physicians and Surgeons, the College of Laboratory Technicians, the College of Pharmacists, and so on. The facility directories, there could be multiple of those. The military might have a facility list. There could be faith-based services that have a facility list. And of course, the Ministry of Health is going to have a facility list. And then organizational directories. And again, there could be different groups that are providing care. And in some markets, of course, there's going to be both private sector and public sector. And so all of those organizational directories will be feeding into that big orange rectangle in the middle. Hanging off the edge of the interoperability layer, we have audit, trail, and node authentication. That's just some of the PKI infrastructure, the digital certificates that authenticate servers and so on. And the audit trail, centralized audit trail, that's a mandatory thing when somebody's accessing a record that leaves the digital fingerprints behind of who accessed what and when. Okay. These can be sort of separated out into feeder systems. Those are the ones that are in green. Real-time systems, those are the ones that are operating in red. And of course, the big orange rectangle is operating in real time. And then companion systems. And that can be the health management information system, but that's also where you'd find the finance transaction processing, the supply chain management transaction processing. And in a really interesting way, it's useful to be able to pull content out of the HMIS, for example, to do claims adjudication for the financing, the health financing aspect of it. Or if you think about if I did a vaccination of a baby, all right, well, that has actually consumed a dose of the vaccine, and I've got a supply chain management transaction that I want to record in addition to the fact that I just did a health transaction. So it's very useful to separate these companion systems out and in fact take things that would otherwise just be creating records in the HMIS and feed it into directly the finance and the supply chain systems to have that fed off of the first transaction as opposed to requiring more transaction processing to be done. Okay, I'm going to get into some more detail here. And as I said, I will share the slides. I'm going to go through pretty quickly. But as I mentioned, this first set of transactions are terminology publishing. So the terminology server on the far left is where I would curate and cross-reference the national lists of normative codes. And then as part of a regular refresh, I make these available to point of service solutions. And as I said, in Canada, we do that quarterly, I'm pretty sure. And Infoway sends out a notice and everybody can download the latest PCLOD, which is our LOINC code directory, and the latest SNOMED CT and the ICD 11, is it 11 now or 10 CA? Maybe it's still 10, ICD 10 CA. Thank you, Roberta, for shaking your head and letting me know which one it was. We're not yet live with 11. So this is a curation. This is library science. I mean, we're doing the job of mapping this to that and taking good care of it all. We're publishing this out to the point of service solutions, but we feed it in to the high-speed transaction processor engine as well. Those curated codes get fed in as fire resources so that they can be part of online transaction processing. And as I said, wicked fast. This is stuff that happens in 200 seconds, 200 milliseconds, 300 milliseconds, sub-second stuff. By the way, the publishing, I can tell you that in France, it still goes out as Excel or PDF files. So the content that's made available to point of service solution developers or that can be ingested in, they're ingesting in Excel files in France. So where I spend half of my time, that's still the method that's used, and it's very common. The transactions might be going through the interoperability layer, but not always. And again, in France, it doesn't go through the interoperability layer. Downloading the normative code list is actually something that's not treated as a highly secured, audited process. You can download those code lists. I could download them. I think it's from the main website. So that's the first thing. Thing two, managing client registry records. Now, there's a number of really important things that have to happen here. Firstly, in order to not be in error creating duplicate records, I will want to always check, so if Derek shows up and Derek doesn't have his card, the first thing you want to do is check to see, well, is Derek already in our client registry? Or does a new record have to be created? And again, just so you know, I've got dirty boots experience in a lot of places where in error, duplicate IDs have been created. And so you also have to be able to curate when a merge is going to happen. And in error, I started collecting information about Derek identified with 123. And then in error, I've got a whole bunch of health data that was recorded against another duplicate of Derek, ID number 456. And I have to find a way to merge that this health data, when I find that the error has been made, I have a surviving ID and then the other content gets merged. And so there's some sort of slow running processes that have to be doable on the CR star. And then when I've gone through the ceremony of establishing a client record, a new unique identifier for Derek, and maybe issued a card for him, then I will update that information into the point of service solution, but also more importantly, into the big orange rectangle. It'll go in as a patient resource into that high-speed online transaction processor. I have the great good pleasure of working for a short time with the people in Brazil. And just for context, Siga Saúde in São Paulo had, at the time that I was there in 2010, 22 million people in their client registry. And one of the things that I was amazed by is that they had framed the onboarding of a new client registry record as a bootstrapping problem. There's an old engineering adage, you have to cast the problem in such a way that it lends itself to being solved. And they knew that if they had to do some kind of big bang and issue 185 million cards, they'd just never get there. And they're so porous in the northern border up in the Amazon that it's a job that would never end. So what they instead did is they said, look, if you have your card, show me your card. If you don't have a card, I will issue you one in the next 90 seconds. And I was so impressed by that. And even on the hospital ship that went along the Amazon, they would have pre-printed cards with barcodes already on them. They would handwrite the demographic information onto two twins, tear off the one, put it in a little plastic sleeve so that it could withstand the rain. And when the hospital ship got back into Manaus, all of that would be keyed into the Oracle server, but they literally could issue you a card in 90 seconds. And I was thinking, wow, my kids' cards came in like 2 days from OHIP, and I thought that was amazing. 90 seconds? Man, these Brazilians taught me a thing or two, and for everybody I've advised since that meeting in 2010, I've said, look, you got to do this the Brazilian way. You have to engineer this so that you can issue cards in 90 seconds. All right, let's move along. Querying for a client demographic record, whereas the onboarding or the editing of a record was on the slow moving process. The querying, you're going into the orange rectangle. And if you need to get Derek's demographic record, there you go. 300 milliseconds later, you've got it. And that's important because you have to have something that's going to respond quickly. And it's going to be handling all the traffic from all the point of service solutions. So these OLTP fire servers are designed for and implemented and operated to handle that kind of traffic. And so I'm numbering each of these transactions. That's transaction 7 along the way here. And so if you think about in a care encounter, I've got a slide that talks about this coming up, but when I was a kid, just to let you know how old I am, when I was a kid growing up on the prairies, we all had to learn to dance in school because you can't be, we couldn't possibly have you come out of grade school and elementary school without knowing how to dance. And so we all had to learn the foxtrot, the 1, 2, 3, 4, the box step one, 1, 2, 3, 4, 1, 2, 3, 4. Well, the 1, 2, 3, 4 is, which Derek are you? That's transaction 7, the one that's on the screen right now. That's 1. 2, what's Derek's health story? 3, provide evidence-based care to Derek. 4, update Derek's health story. And wherever I go throughout the care delivery network, it's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Which Derek are you? What's your current health story? What should I do for you based on what's your story? And then update the health story for next time. And that repetitive step, this is the first part of a care encounter. Which Derek are you? Transaction 7. And we saw that in the video. So every time Amar went to a different point of care, it was retrieve his demographic record. And actually, when he went to see his primary care doc, he had just got a new phone. She updated the demographic record. That was number 4. And then the content from the updated demographic record made its way into the high-speed fire server. So that was part of the video that we saw. We saw transaction 7, and we saw, I'm going to go back up a little bit here, we saw 4 and 5. The updating of his phone number, because he got his new phone, and in transaction 5, that moved from CR star into the big orange oval, rectangle. Okay. That's the 1 of 1, 2, 3, 4. 2 of the 1, 2, 3, 4. Query for a client's patient summary. So now we've established which Derek are you. What do we know about you? And this is where we go to the shared health record repository and we fetch Derek's patient summary, transaction number 8. And ideally, that patient summary will be generated on demand by the SHR. That is the gold standard. And that's what we're working towards in Canada. And to be honest, that's the way we're working towards it in Europe as well for the European projects that I'm doing. So transaction 8 is saying, okay, we know which Derek you are. What's Derek's health story? And again, that was part of every care encounter that we saw during the video. First thing, Amar would show his card, and the next thing they would pull the health story from the HIE. Now, step 3, now that we know which Derek you are, and we know what is currently true about Derek, now we go through a process of saying, okay, I'm going to pass this information to a computable care guidelines engine. And if Derek is currently receiving evidence-based care for his hypertension and for his diabetes, it's going to say, okay, here's Derek's health summary information. What recommendations fire true at this point in time? What should you do for a hypertensive diabetic 62-year-old man who's just presented for care? And if the data in my patient summary shows that my last HbA1c was 9.5 months ago, then the CCG engine is going to return, among other things, order a blood sugar lab test for Derek, because the guideline is that you do that every 6 months, and he's 3 months overdue. So this pattern is between the point of service solution and the CCG engine. Now, keep in mind, some EMRs are going to include the CCG engine as part of the code base. So this may or may not be a transaction that's going to an external service. I can tell you that in Ontario, we're sort of favoring the idea of a service that would be hosted by Ontario Health. And that is the way the NHS Scotland does it. That is the way the Danes do it in Denmark. So it could be part of the code base or it could be an external service. But that's the pattern here, that we're taking Derek's information, we're submitting it to the service, and we're seeing what comes back. And we see that that was in the video. So part of the things to come back to say, well, every time you see Amar, take his blood pressure, weigh him, and do a spirometry reading. And so we're sending the information that we have about him, and then the cards are coming back, the responses are coming back, from the CCG engine, to say, well, take these readings. And then based on those readings, well, we have to update his inhaler. We're going to change his inhaler prescription, and we're going to send him on a lung cancer screening test. This spirometry is really worrying. And again, we always recommend it. Amar, it's a good idea for you to do a smoking cessation program. And again, he said, no, he doesn't want to do that. So this is a recommendation that would come back from the engine, and the clinician would not say, yes, we're going to do it. She'd say, no, we're not going to do it because the patient doesn't wish to. Okay, so we've done which Derek are you? What do we know about Derek? What should we do for Derek based on his conditions? And step 4, update the patient summary. That's transaction number 9. And here's where something very interesting can happen. You see the fast path here, because this is, again, that high-speed online transaction processing server. So transaction 9 goes straight in, that information gets persisted. And we see that that's what happened in the video. Oh, you know what? I'm saving my cool stuff for later. I'm going to skip this. You can also query for registry content. You can fetch locations. If you want to do a referral for Amar, you can find out what the closest place to his home is. You can do all kinds of transactions. And there's a particular conformance testable transaction to do that. You can query for codes, and you can map codes to each other. I'm going to skip past that because of this one. When I'm on the fast path, transaction 9, that's going up to the shared health record repository, there's an engineering pattern called just a T-junction. And I can intercept that fast path content that's going to the shared health record repository, and I can just make a twin. It won't take any time at all. I won't get in the way of the fast path at all. But this twin, this transaction 9 star, can now go through a slower process. It could go through a de-identification process. And now I can start to feed an HMIS that has de-identified person-centric content. This is this isn't gold, this is platinum. This is exactly the kind of stuff that at Kai, for example, they are aching for this. And this is sort of in their strategic plan to say, how would we start to tap into de-identified person-centric content because of how amazing it is for doing analytics. Super amazing for doing analytics. And graphically, we're showing that, okay, I can submit aggregate data to the HMIS. It's pre-aggregated, and that's of some value. Or I can take person-centric content into the shared health record reports repository and aggregate from that. Or I can use this T-junction idea and go through an automated de-identification process. And on the right, we're just seeing that over time, you'll start submitting fewer and fewer aggregate reports and start getting more and more person-centric content. And I see, Lisa, you have your hand up, please.
Is that, so I've heard of the term digital twin. Is that what you're, does that term go along with what you just talked about of you splice off, like you get a copy for
Uh,
analytics?
so it's similar and not the same. And the reason it's not the same is my digital twin is actually identifiable as being me. And this is quite intentionally de-identified. And the reason why it's not exactly the same, there are some absolutely wonderful open data initiatives where this de-identified content, you can provide access to this de-identified content to innovative companies that want to start to train AI bots or to researchers that want to be able to do analytics. And the digital twin is my twin, and so you can tell it's Derek's. And this one is a completely de-identified one. And because it's been sufficiently de-identified, and there are statistical processes. In fact, one of the clever heads over at Statistics Canada is a global leader in the cryptography that you use to create de-identified content that can't be re-identified. Now, for anybody that's seen some kind of demonstration where it says, oh, well, we are actually able to re-identify this using their Facebook content or using this other stuff that they've been putting on social media, that is not on the statisticians. Do not be, saying anything against them. If you're sharing that much personal information on your social media feeds, that's on you. That is that is not on anybody else. By the time you're sharing that much content that the re-identification can happen, that's because you decided to not be private. But you could have been, and there's sufficient cryptographic strength that if you decided you didn't want to be so divulgent, your privacy would be maintained. I also should say, and this is under the general heading of Canadian apologies, the digital twin work, there's some fascinating stuff going on, and it's not my practice area, so I'm not an expert in that. I'm kind of reasonably knowledgeable, but not expert. And I'm sorry, Lisa, if I can't give a more fulsome answer, but
No, I think,
can't be an expert at everything.
no, I think actually that totally answers my question. I, I think it was Verosource. I'm in New Brunswick. I sat in on a presentation from them, and
Okay.
they talked about that they're doing some exciting things with this concept that they had called digital twin. And I thought, oh, that sounds interesting. So now I understand the difference. So thank you.
So one of the ways that I think people are hoping to be able to use it is to say, well, I have data that is about me, that is the curated data that is true about me. And with my digital twin, I can play what if scenarios. It's like the spreadsheet version of my data. And so you could play with it a little bit. And that's very powerful, very powerful. And
Interesting.
it is interesting. And like I said, there's some very cool stuff that's going on there. And I'm now I'm going to pick up my pace. You can refresh interlinked registry information. The HMIS, by the way, is a great source of that. In many countries that I've worked in, because they're doing monthly reports, the HMIS is actually a wonderful organization registry and facility registry because it's mandated by the Ministry of Health that you have to do a monthly report. And so everybody who's doing the monthly reports is identified to the HMIS. And so that's a terrific way to update that big orange rectangle with content that's very up to date and very fresh. And there's a product that's been very widely adopted. Like over 100 countries have now implemented it, called Digital Health Information, or sorry, the District Health Information System version 2, DHIS 2. And both Linda and I have worked with those clever people. The Oslo University in Norway has been the home for that open source project for years, and it is very widely adopted. Okay, privacy and security and auditing, it's not a may have, it's a must have because we work in a regulated environment that has to keep private content private. And so there would be these elements in the interoperability layer that are making sure that no stranger is able to get into the big orange rectangle or any of the cloud assets. We don't want strangers. The HIE never talks to strangers. Now, there might be architectural elements that have been deployed. In many of these countries, they could have, for example, a big client registry. They'll have, in Cambodia, we had a database with about 8 of the 11 million Cambodians already in there. And so we want to be able to make use of that. It's not a standards-based thing at all. And so one of the things that is a very useful approach is to leverage what's called a facade pattern. And a facade pattern is exactly what it sounds like. So we have a legacy software solution that has a proprietary interface, and then you put a FHIR-based facade on top of the proprietary interface. And this gives us a way to embrace a running start in countries that are trying to implement their national digital health infrastructure. And they have a few places where there are wonderful data holdings or solutions that are already in wide use and people are already trained on, but they're not standards based. We use the facade pattern to add the standards-based element to that. And so this is just the same picture showing where you might be able to leverage facades to do that running start. I'm actually going to go really quickly through this because it's not as germane for us. What I do want you to do to take away here is that there are, when I'm advising a country that's maybe setting up its first national data sharing infrastructure, they're looking for where can they get products that do this. And so it really boils down to only a few things they're looking for: client registry, terminology server, FHIR server, HMIS, interoperability layer, and then point of service solutions. And then these are just some of the products that are favored because they're open source initiatives that are well supported, and they are ones that these countries can look to that are going to work, that they can join a large community and leverage them, and leverage these open source projects and join as contributors to those open source projects. And so that's a quick list of those. All right, the key takeaways here. And I'm going to make myself take only 10 more minutes to go through the rest, just because I really want to have lots of time for discussion afterwards. Key takeaway points. The Open HIE infrastructure is assembled out of a small number of, as I said, digital Lego blocks. The technical configuration has to define performance. And one of the kind of junior mistakes that I've seen made when somebody goes from pilot to try to go to deployment is that they had a pilot where they had one server that was trying to be the OLTP engine and do some of the slow running batch processes. You have to separate concerns. One of the truths about these projects that are large scale infrastructure projects is you have to do the engineering around being a large scale infrastructure project. And this is part of the engineering of that infrastructure. You have to defend performance. And it's been a failure mode for so many of these that as they try to go to scale, I've got terrific results from 3 or 4 villages, and now we're going to deploy it countrywide. No, you're not. It's not engineered for that. The way that you did those 3 or 4 villages forgave you the fact that you had not engineered your infrastructure correctly. And now that you're trying to go to scale, you're going to run into a brick wall because when performance declines, usage falls away. Clinicians will not wait 35, 45 seconds. None of us can stare at that little hourglass for 35 or 45 seconds and not want to just chew our own paw off. So the T junction is very smart because it gives us a way to start to drive the analytics that you can do with person-centric content. It also is how we can connect to the companion processes. So when I did that vaccination of the baby, I did that consumption of the dose and created the supply chain transaction. Or when I delivered this service to Derek, I did this lab test. It goes into the finance and health financing side of things automatically. We can embrace legacy solutions where we find them by this software facade idea, and it's very powerful to do that. And just happy news for any of the clients that I've been advising on this topic. There's multiple conformant open source and commercial options for any of these Lego blocks. And that's a very risk mitigating thing. And it's also it gives people comfort. It's a comforting thing to know that there's not some idiosyncratic, started from scratch, stick built my own thing. I mean, this is a way that we can leverage Lego blocks that click together and can be configured to do what we need them to do in our country context. Okay, I'm pausing for Q&A. I do have more slides, but is there, and I get it, I ran through a lot of content there, but what I really want is for your subsequent lectures that you're going to see, I want this to be a clear box for you, not a black box. I wanted to give you an insight into, when we leverage digital health to do these things that are important for us to be able to do well, there's actually only a very few things that are going on back there. And they happen wicked fast. But I want this to be a clear box for you. I want you to feel like you're in command of these ideas. Questions, please, if you have any. Okay, I go. We're not doing this. How do we capture health value from our digital health investments? So I want to introduce here that there are two quite distinct concepts. There's value creation and there's value capture. Value creation and value capture, and they're not synonyms. So this is a diagram. Just think of this. Think of the blue circle as everything you should do in a care encounter. And think of the yellow circle as everything you did do during the care encounter. The game is to maximize the amount of care in the green zone. That's how we capture value. The act of making our digital health investments, the act of having computable care guidelines that we've meticulously created, that's all value creation. And at that moment of delivering care to a subject of care is when we do or don't capture that value. So the relative sizes here are indicative. Our clinicians actually don't commit that many errors of commission. It's not that often that we do the wrong thing. It is very common that there's something we should have done and we didn't do it. Errors of omission outpace errors of commission by 10 to 20 to 1. Now, computable care guidelines are a way to describe the blue circle. So this is a way to take the WHO normative care guidelines for HIV and describe that in a way that a computer can ingest and understand and operationalize. And that means that we can leverage our digital health investments to be systemically closing what WHO calls the no-do gap, the sometimes wide chasm between knowledge and practice. And these CCGs define the minimum data set, the care logic, the indicators, and so on. And it gives us a way to leverage our investments to be delivering care in the green zone. What mandatory behaviors do we need in order to be able to do this value capture? Again, this is a little bit geeky, but this is just a BPMN diagram, a business process modeling notation diagram, that shows there's really not very many things that a point of service solution has to do. It has to be able to do transaction 78 to do a lookup of the patient record, which, Derek, are you. It has to be able to add or update information, demographic information, if that's needed. It has to be able to fetch to look for and fetch the patient summary. That's transaction 8. It has to be able to do 9 and 17, which is give me guideline adherent care, and then transaction 65 to update that encounter when the time comes. And this is that 1, 2, 3, 4 that I introduced earlier. The pattern repeats itself throughout the care delivery network. At the voluntary counseling clinic and testing clinic, where you would identify Mosa has HIV, and that at a district clinic, where it turns out that she is pregnant and she's receiving her HIV meds, because that means we're doing PMTCT, Prevention of Mother to Child Transmission Protocol. The fact that she's HIV positive and pregnant means we should do PMTCT. And if we do that, I said if we do that, then the likelihood the baby is going to be born HIV positive goes from just over 30% to just under 2%. This is a very important thing to get right for Mosa and her child. I'm not going to do that. Key takeaway points. The 1, 2, 3, 4 pattern can systemically improve guideline adherence. And doing that at scale means we start to get population health outcomes that track the RCTs that informed the guideline in the first place. That is astoundingly important, and we in Canada need to do better at that. In Canada, the last numbers we have are that we get diabetes care right about 1 time in 4. That is not good. We need to up our game, and we should leverage our digital health investments to help us up our game. The other key takeaways here, when you collect data in a CCG-enabled encounter, you always collect coded data. That supports the analytics, and that good data, the de-identified person-centric data, is, as I said, platinum for AI-based analyses. Okay, I'm going to do this super quick and then we stop. This is just, all right, answering the question, how does digital health impact health? This is not controversial. Health interventions yield population health. This is a little bit controversial. Digital health infrastructure operationalizes the health intervention. I disagree with some of my health informatics colleagues who say that digital health is a health intervention. I think it actually is an industrial engineering intervention. The role of our digital health investments are to help us more repeatably, more consistently execute our health interventions. And when we leverage standards-based digital health, we generate person-centric transactional data that is in a computable form. And now we can leverage that data to start to do population health level and generate population health level metrics. And we get to pick what level, like at the person-centric level. Well, that is by definition our longitudinal health record if I'm aggregating at the person. But I can aggregate at the provider level and I can use it to support performance-based financing. I can aggregate at the facility level or the regional level, and I can use it for health system management, or at the national level and get all of those golden Chi-Hi metrics that we have to show what the health of Canadians is. I can leverage this information as part of a feedback loop to inform continuous quality improvement of not only the health infrastructure, but sometimes the health interventions themselves. We leverage data analytics to make a change to the global guideline for HIV care because we saw that something was working better, and it was the data that pointed us to that. This is, by the way, the learning health system. That feedback loop is the learning health system. And I'm not going to make it a trick question or anything like that, but the act of using digital health to operationalize the health interventions themselves, that's called feed-forward process control. The feedback process control is the big loop. But the fact that I'm using digital health to do the right thing in the first place is called feed-forward process control. I'm going to give you the benefit of 5 years of engineering school. It's going to take me only 20 seconds. If you're putting your hand in the water in the tub and adjusting the faucets, that's feedback because you are sensing the present state of the system and making adjustments to controlled inputs. Every parent knows you put your hand in the stream if you've got a baby in the tub. And that is feed-forward process control. You are not waiting for this input to have its impact on the system. You are making adjustments based on the feed-forward detection of the stream, because you don't wait till you scalded the baby before you make an adjustment. Feedback and feed-forward. There you go. 5 years of engineering school for me, 25 seconds for you. What are the implications for AI? Let's look at our blue and yellow circles. What if there's things that aren't indicated as care activities, but they yield systemically better outcomes? Or what if there are things that are indicated, but if I omit them, I get the same or better health outcomes? We can leverage analytics, very mature analytics that we use today to detect credit card fraud, because we're looking for something that's a negative outlier for credit card fraud. These would be positive outliers. And there's very simple analytic tools that we could use in our yellow section and blue section to inform updates to the care guidelines themselves. Okay, now I really am done. Actually, I'm not really done. Now I'm done. I am retiring this year, and this is my career advice for you all. Navigate to the center of this graphic. Find what you love. Invest in yourself so you can do it well. And the overlap between that and what the world needs and what the world will pay for will give you that sweet spot in the middle. I've had the great good fortune to spend the last 20 years there in the middle. And it gets you out of bed in the morning. Now I'm done.
And aren't those of us that find that middle point the luckiest people in the world?
Isn't that the truth?
Yeah, yeah. Thank you so much for your wonderful presentation, Derek. That gave us a great overview of the digital health space and also some really interesting insights from your experience over the years. So much appreciated. I'm very glad that you learned to dance in school. And I also appreciated the icon of de-identified person-centric data, the fingerprint with the mask. I thought that was particularly cute. But does anyone in the audience have any specific questions for Derek?